So today we'll look at stationary points and the second derivative. So here we want to gain the knowledge of calculating the stationary points by using the first derivative and then determine its nature using the second derivative. And determining its nature is telling me what type of stationary point it is. So we'll be successful if we can calculate the stationary points and determine the nature. Okay. So this little table shows us the type of first derivative. So if the first derivative is greater than 0, but the second derivative is greater than 0 as well, then it's going to be concaved up and it's increasing. If it's the first derivative is increasing, but the second derivative is decreasing, it's going to be concave down. If the first derivative is greater than 0, but the second derivative is 0, then it's going to be a point of inflection. Okay. Alternatively, there's the table for decreasing in the first derivative or stationary. So, stationary points and the derivative. The minimum turning point will occur when the first derivative is 0 and the second derivative is greater than 0. So, when there's a stationary point, but the rate of change at that stationary point is increasing. So it's increasing, so it will make a minimum turning point. Otherwise, if you have a stationary 0 at 0, but the second derivative is decreasing, then you're going to get a maximum turning point. Okay. If f of x equals 0, f of double of x equals 0, so the first and second derivative equals 0, and there's a change of concavity, then it's a horizontal point of inflection. Alright, let's find the stationary points on this function and determine their nature. So the first thing I need to do is find the first derivative. And I can factorize that. Okay, and then the second part is to get the second derivative. Okay, so from the first derivative, if I let y dash equal to 0, we get x to be either -3 or -2. Okay. So what I could do is I could do a table in a second. So when x equals to -2, I'm going to plug this value into the second derivative. Y double dash would be so -24 plus 30 is -6, is +6. So which is greater than 0. So then we have a minimum turning point. When x equals to -3, so 36, we get a negative number, which is less than 0, so we get a maximum turning point. Okay. What we should do is, to find the stationary points, we really need to plug these values back into the original function. So, when x equals -2, y equals -78. So, and that's a minimum turning point. And so when x equals -3, just changing it, plugging it back into the original function. We get a maximum turning point. Okay. Alright, so next example. Find any stationary points on the curve and determine their nature. Alright, so this is a product rule with a chain rule into it. So I'm going to give us the derivatives. So the first derivative ends up being -13 plus 3x over, no, that's the second derivative, sorry. The first derivative ends up being 11 minus 3x over 2 lots of the root 4 minus x. Okay, and the second derivative ends up being -13 plus 3x all over 4 minus x, 4 minus x square root. Okay. So I'm going to let you try to do those derivatives, but they're the solutions for the first and second derivative. So what we want to do, we want to let y dash equal to 0. Okay. Now, we don't want anything on the denominator to be 0 because then we can't divide by 0. But what we could do is have the top being equal to 0. So 0 divided by something gives us 0. So we really want 11 minus 3x equals to 0. So x equals 11 over 3. So that's where a stationary point occurs. Okay. We could find out from, so when x equals 11 over 3, y would be approximately 0.3849. Okay, that just to figure out the point. Using the second derivative, let's plug in. So when x equals 11 over 3, the second derivative is going to be okay. Plugging it into our calculator. I get negative 2.5980. Okay, so which is less than 0, which means that less than 0 is a maximum turning point. So to conclude, so at this point, there occurs a maximum turning point. Okay, good luck.